Welcome to the exciting world of full stack web development with MERN Stripe course. Here, you'll learn the ins and outs of building a robust application using MongoDB, Express.js, React, and Node.js, all while incorporating the user-friendly payment gateway Stripe. Our aim is to provide you with a comprehensive understanding of the process from project setup to successful Stripe integration. And for those who prefer to have the source code and accompanying blog articles at their fingertips, they are available for purchase on epicprogrammer.org for just $30. Whether you are a beginner or an experienced developer, this course is designed for you. And if you like to support our channel and see more courses just like this in the future, consider purchasing the source code on epicprogrammer.org for just $30. Not only you will gain access to the code, but you'll also be helping us continue to produce high quality content for development community. So, without any further ado, let's start this journey and start creating innovative web applications with MERN and Stripe today. Handling payments at a global scale is not an easy thing to do from scratch. You have to worry about things like PCI complaints, encrypting credit card data, storing credit card data securely, and all kinds of other regulatory issues that you'll never able to do as an individual developer. Stripe, which is now one of the most valuably private held company, makes the entire payment handling process very straightforward and accessible to the average developer or team. It takes care of the security and compliance requirements and exposes a simple API that you can use to build a customized payment flow. It's been extremely popular with startups and scales up to the highest level. I like to think of the Stripe API as a building blocks for handling any type of payment scenario. The most simple use case would be a single payment for a single product, but you might expect this user to return in the future. So you might have to save their payment details, or you might set up a recurring subscription and maybe you need to apply a coupon or discount to that subscription. Or maybe the user can purchase additional add-ons to their subscription or build dynamically based on their usage of your application. Stripe can handle all of this and more, and to get the ball rolling, you'll have to go ahead and sign up for a Stripe account if you haven't done so already. After you sign up, you'll have to access the Stripe dashboard. The dashboard allows you to manage customers and see all your payments and subscription and all that good stuff. It also provides reporting and analytics that you should find useful, but the dashboard is really just a user interface for making calls to the Stripe API. The same thing we'll be doing from our backend using JavaScript code throughout this course. Let's go ahead and take a look at how this works. First, go to the dashboard, and at the top right corner, you can find the test mode. Just flip the switch on. This gives a full sandbox to create and modify in a way that doesn't pollute your actual real live data. Stripe provides a bunch of testing cards that we'll look at that later, where we can create a fake charges in testing environment. We'll be using test mode throughout the entire course until we get to the end when it comes time to deploy the actual application to the cloud. Now, let's go ahead and create your first customer manually. On the dashboard, you can add whatever information you want for the customer, but the main thing that you'll want in a production app is the email address. If you click on it, you'll see the details that you have said about the customer, as well as the option for adding credit cards, payment source, and things like that. But by clicking on create customer button, what we actually did there is made an API call to the Stripe. Specifically, we made a post request to a customer's endpoint, and we can see that here on the dashboard because Stripe keeps a log of everything that happens to this customer. This is extremely useful for debugging. And if you go to the developers tab, Stripe will show you where all the errors are occurring throughout your application, because you are likely going to be interested when it's an error versus a successful request. Now, back in our customer's record, if we click on the log entry, you can see it will tell us exactly what was sent in the post request and back from the Stripe as a response. If you are new to the API, this is a very important concept because everything in Stripe follows request response pattern. We made a request to the Stripe API to create a new customer, and we provide this JSON data as a request body for the data to use when creating that customer. Stripe received that request, then created the customer on the Stripe server. Then it responded back with the newly created customer information. The response JSON contains a bunch of data that's explained on a Stripe documentation, and most of it you won't need. In fact, it's very likely that only one thing you'll need is the customer ID. This will allow us to later attach a credit card to that user or create a subscription or anything else we want to do related to this customer. The main point I want to get across here is that everything in Stripe is just a request response pattern. You make a request to a specific API endpoint with some data. Stripe will try to execute whatever you're requesting, like charging a credit card, and then Stripe will respond back with all the data you could possibly want related to that request, like whether or not the charge was successful. Now, in most cases, you'll be making a request to Stripe from your API, but there are some cases where Stripe might need to contact you when something has happened on the API. Like for example, if you have a recurring payment setup and you want to be notified when the payment has been paid or if it has failed to pay. The way we facilitate this is with webhooks. We'll look at this more in the building section of this course, but I did want you to provide a quick primer for you here. Basically, it allows you to listen to different events that happen within the Stripe API. When these events happen, Stripe will send a request to your API endpoint, and request will contain a bunch of data that you can act upon. For example, if you have a recurring payment and the payment fails to go through, you might receive the request from Stripe, then update the user's record in the database to post you. So in other words, webhooks provide a way for you to listen an important event that happens within the Stripe API. And again, we'll look at those settings later in this course. So that's the basic overview of Stripe and what it can do for you. Now we'll look at how these API keys work within a Stripe project. One thing that can be confusing when you first get started is how API key works in Stripe. An API key can authorize your frontend or backend code to make calls to the Stripe API. You can find your API keys under this developer tab, and you'll have the different API keys depending on whether or not you are in a live mode or test mode. The most important thing to know is that your publishable key is only used in the front-end code, while the secret key is only used in the back-end code. Notice that the publishable key is visible here in the UI. That's because it's safe to expose to anybody. It'll be bundled up in your front-end code, and it's not a big deal if a user sees it. Essentially, it just identifies your striped projects so you can do front-end things just like collect credit card information from your client-side applications. Now, the secret key is a sensitive piece of information, so you want to make sure to keep it out of any kind of public key repo and definitely out of your client-side application bundle. The secret key is used in your backend code to do things to the Stripe API like create customers, charges, and everything else you can think of. It acts like a username and password that gives your server full access to your Stripe account. I'll show you how to securely manage this value as an environment variable in your backend code. The secret key has access to do anything to your Stripe account. If you want a little more carefully, you can create a restricted key. This allows you to manually define what privileges that API key has. So if your API key does accidentally get exposed at some point, the hacker that has it will only be able to access to a limited subset of actions on your Stripe account. It's totally optional, but it can be good practice to replace your secret key with a restricted key just for security benefits. Now, the main takeaway here should be that the publishable key is for your front-end code, while the secret key is for your back-end code. The secret key, as the name implies, it should be kept secret. Now, let's make our first API call to the Stripe and learn everything. You need to know about RESTful APIs. Many things in Stripe need to be done on your own backend server, like creating a payment intent, creating a checkout session, creating customers, etc. So we need to create a server that can listen to requests from our front-end code, handle whatever backend operations need to be done, then send the results back down to the client or front-end app so it can show the data to the user. That means we need to build an API that can handle HTTP requests. There are many possible ways to do this in Node, but by far the most popular is Express.js. It allows us to easily create a RESTful API, but what is a RESTful API? You might ask. Well, it's essentially just a set of URLs on the server. Each URL is related to a specific entity, and when you make a request to that URL, you can send a request method depending on what you are trying to do. There are many different request methods, but the only ones we'll be worried about in this course are get and post. You make a get request when you want to read some data from the server. For example, if you wanted to get all of the user's past payment from the Stripe API, in this case, we're just reading the data. We are not modifying anything on the server. Whenever we create something, we send a post request. For example, if you wanted to create a new payment intent, we would send a post request to our API. Now, before we jump into the code, I would highly recommend that you have an HTTP client installed on your computer. I'll be using one called Insomnia throughout this video, but Postman is a very popular option. These tools make it very easy to send requests to your own API or directly to the Stripe API. A client like this is both great for learning and just for practical debugging. Let's go ahead and look at this in action. By making our first request to Stripe API before, we created a customer on the dashboard. Let's see if we can retrieve the customer from the Stripe API directly. In Insomnia, click on the plus icon to create a new request. Notice how you have the options between different HTTP methods, but in this example, we'll just want to stick with the default get method. Now, in order to make a request to a Stripe API, we need to authenticate, which we do with our secret API key. We can grab our secret testing key from the Stripe dashboard, then click on the authentication tab. In Insomnia, we'll have to use a barrier authentication and we'll set up to create a secret token as a value. And now in Insomnia, we'll want to use barrier authentication and we'll set up the secret token as a value. And now we just need to figure out which RESTful endpoints we want to call. Here in the Stripe dashboard, you can see the customer's record. Now, if you go over to the documentation to the customers section, you can see there is an option to retrieve an individual customer. Now, if you click on the code for C URL, it will give you the full URL to this endpoint. You'll notice that the URL is customer/the customer ID. Now, we can go and paste that in Insomnia and send the request. And you'll notice that in this case, it sends an error back. because that the customer ID doesn't exist in our project. Now, if you go back to the dashboard and grab a customer ID that doesn't exist and use that in the URL, you can see we get the full customer object back from the Stripe. So that's how the RESTful APIs work. Throughout this course, we'll be making the request to the Stripe API, but primarily we'll be doing that through our source code and Node.js. And having an HTTP client like this is very useful for debugging your own API, as we'll see throughout the course. Now, we'll set the Node.js project and optimize it for reliability and productivity. Now, we'll set up a backend Node.js server. I'm starting with an empty directory and VS Code. Then I'm going to create a directory named server that holds all of my backend code. Now, the version of Node.js that you use depends on whatever it's installed on your system right now. But for this course, I recommend installing Node.js version 16. You can easily do that with Node Version Manager. There's a package for Linux and Mac and a separate one for Windows. Once you have installed, you can run the npm installer version 16 command, and this will ensure that you are working with the Node.js version that will ultimately deploy to production. At the end of the course, npm will also install Node Package Manager or npm. We can set up a basic Node project by opening the command line and then running npm init with the Y flag to use the default settings. That should create a package JSON that allows us to install external dependencies into this project. Now, I recommend you to use the dependencies that are listed below this video description, because if you use the later version, there could be a breaking changes that affect the code later in this course. But that's just a recommendation, and you're welcome to use the latest version. And if you notice any breaking changes, please let me know. You'll notice a variety of dependencies in here, and I'll explain these as they come up in this course. Go ahead and save the file, then run npm install and install everything. The one you want to be aware of right now is TypeScript. It's used in this course because it provides inline documentation for the Stripe API and makes your code much more robust by making it difficult for you to shoot yourself into the foot by passing the wrong information to the Stripe API. To set up a TypeScript, we'll add a tsconfig JSON file and a tslint JSON file to this project. I'd recommend simply copying and pasting the values for these files from the main source code. The tslint is just for code formatting, but the tsconfig file determines how your code is actually compiled to raw JavaScript. If you have never used the TypeScript before, there's a couple of things you'll want to know about the tsconfig file. The first one is that it looks in our source directory and grabs all our source ts files and then compiles them to the outdoor file just named lib. To see this in action, go ahead and create a source directory and then add a file named index.ts. For now, we can just add some simple JavaScript inside this file. At this point, we need a way to transpile our TypeScript code to JavaScript code. Open up your package JSON again, add a script for build. We can build or compile our code using the tsc command or TypeScript compiler. If we run npm run build from the command line, you can see that it creates a lib directory and adds our TypeScript code there. As raw JavaScript, you should never modify any of the code in the lib directory because it will always be overridden by TypeScript. Now, we can run our code in Node.js by adding a start script. The start script will run node lib index.js to run this file with Node. So those two scripts will build your code and run your code. But in development, you're often making code changes very frequently, and you'll want the TypeScript to automatically recompile that code and Node to rerun the latest code. So in order to facilitate that, I added two packages to this project in development called concurrently and NodeMon. Concurrently simply runs two processes at the same time. NodeMon will monitor a JS file and then rerun it anytime when the source changes. Now, with that being said, we can create a dev script that will concurrently run TypeScript and use the W flag to watch the changes and at the same time run the NodeMon with our lib index.js file. The end results here is essentially hot reloading for a server code. So anytime we make changes to the TypeScript file, they'll automatically be reflected to the server that's running in the background as you go through this course developing your own code. I recommend using a dev script so that your changes are reflected in the whatever API calls you're making. Now let's go ahead and switch gears into another important concern: environment variables. In Node.js, we can use a package called env to manage environment variables on a system. Go ahead and create env file in your server directory. And you'll also want to make sure that this file is added to your git ignore because you'd want to expose it in public repo because it could contain sensitive information. In fact, let's go ahead and set up an environment variable in this file called Stripe secret. Make it equal to the Stripe secret testing key from the dashboard. Now, the purpose of env is to load these values into the server at the runtime. Go into the index.ts file, then import config from env. When the node environment does not equal production, we want to load these values from this env file. In production, we'll use whatever environment variables are available in our Docker container or server, which I'll explain in detail in the deployment section. Now that we have our environment variables, we can import the Stripe SDK. We can then instantiate the Stripe client using the API key, which allows us to easily make an API call from our Node.js code. We can also specify the API versions, and you want to make sure to use the same API versions that I'm using in this video. And now our backend is ready to start interacting with Stripe. Now we're going to work on Express.js by setting up our first RESTful endpoint. Now we have a server setup. We'll give it ability to send and receive data over HTTP, or in other words, we'll build our own RESTful API from scratch with a library called Express.js. Express is most popular web application framework for Node. It's very simple and very minimal. To get started with Express, we'll create a file called api.ts. This file will define all of our URLs or routes that the user can access over HTTP. The first thing we'll do is to import Express, and then we'll instantiate a new Express app. The app is your API. It receives incoming requests and sends outbound responses. But in order for it to do that, we need to first start it up. Let's go ahead and do that. In the index.ts file, we'll import our app there, and then we'll define a port for it to run on. The port usually comes from the environment, or we'll set it to 3000 as a default, and then we'll run app listen on that port, and then we'll console log that whether it's available on localhost or whatever the port is. Remember how we set this up earlier to compile the TypeScript code and also restart the server anytime the source code changes. So you should see that serving on localhost 3000. Now at this point, our API is running, but we don't have any actual endpoint to use. First, we specify the HTTP verb that we want to use here. We could use get or post or anything else. Then the first argument to this method will be the URL to that endpoint, which in our case will just be test. The second argument is a callback function that you refine to handle an incoming request. To this endpoint, the request is the incoming data, the response is the outgoing data that you send. And we can strong type this with TypeScript to get autocomplete on all methods available on these objects. Something we'll commonly do is send some data from our front-end application in request body. We can access that data by calling request body followed by the property of whatever data is there, which will be in JSON format. We'll receive the data and then do something useful with it, like make a call to the Stripe API and then send a response back down to the front-end application. A response can optionally have a status code, and there are a bunch of different status code to choose from, but a generic OK response is status code 200. If there is an error, you would generally send a status code and starts with a 4 or 500. From there, we'll send the data back down to the client by calling send with JavaScript object. And we'll just go ahead and multiply the amount by 7. And that's all it takes to set up an API endpoint with Express. But there's a couple of other considerations that I want to take care of here. By default, Express handles the incoming body as a string, which means we would have to decode it and paste it into a JavaScript object on every request. We can avoid this by setting up middleware that changes the behavior of Express. We do that by calling app use, and in this case, Express has built-in middleware to allow us to convert the incoming body to JSON automatically. In addition, we want to make our API accessible to other URLs, like our front-end application. When it starts making requests to this endpoint, we can take care of that requirement by importing a library called CORS, or cross-origin resource sharing. When we set the origin to true, it means that any other URL can access this API. So our API can be running on localhost 3000, but our front-end app running on localhost 5000 can still access it. So we're just being proactive here to make sure that our front-end code will work. When we get to that point a little bit later in this course, let's go ahead and test it out in Insomnia. We'll create a new request, making sure that it's in a post request, and we can pass in some JSON as a body. Remember, the JSON that's expected here is an amount with a number value. And then we'll go ahead and add the URL for localhost 3000. The actual endpoint is triggered from /test. When we send it, we should get a 200 status code back along with the tags property and the value multiplied by 7. We now have the working Express app, and now we're going to be switching up our gears to the front end and start building a React app. Now we'll get this up and start running with React. And remember, if you're not using React, you can use many of the patterns found in this video and apply them to the front end frameworks of your choice. The first step is to generate the initial app, and we'll of course use create React app to do that. Then npx create React app with the name of your app to get started. This will generate the initial boilerplate code for us, and then we're going to install a couple of dependencies. The first one is a Stripe React library. This library will give us a bunch of UI components and hooks that makes it easier to work with Stripe in a React app. One of the first things you need to do in your front-end application is to load the Stripe.js library, and this library needs to come from a script tag. Normally, that's because in order to PCI compliant, you must always put the latest JavaScript code from Stripe. You could go into public folder and add the script tag to the head of the HTML document there. However, this Stripe library allows us to handle this automatically from our React code. We'll import two things from the libraries we just installed here. The first one is load Stripe, and this function will be automatically add script tag to the head of the document for you. We'll also import elements from Stripe's React library. This is a provider that allows us to access the Stripe React UI components in our React app. We'll create a variable called Stripe promise that asynchronously loads Stripe and makes it available in the application. It takes one argument, the Stripe publishable key, which you can find it on the Stripe dashboard under API keys. In our case, we'll just make Stripe elements available everywhere. However, you could scope this further down into the component tree if you just want to make them available in, say, a checkout page or something similar. But essentially, what we are doing here is just making Stripe accessible globally throughout the application. The next dependency we'll use in this demo is React Router. We'll have multiple pages in this application that handles different situations in Stripe, like checkout payments, customers, and subscription. Once that's installed, we can go into our app.js file and we'll set up all of our router logic in here. I don't want to spend much time talking about React Router because we have a very simple navigation layout. Here, we have a nav bar that contains links to different pages, and then we use switch to organize our routes. And each route will have a path that points to one of these links. And these components are what we'll be building throughout the course. I'm showing you the full router config here, but we haven't built this component yet. And we'll get to those later on this course. Now, one last thing that I'll mention that I'm using Bootstrap CSS just to give us some better looking buttons and UI components. In general, you'll find Bootstrap style reference in the head of the document, and you'll also see some styles here in our index.css. We are not going to cover any CSS in this course, but that's where the style out just in case you are wondering. And lastly, you might be wondering why we haven't set up a Firebase yet. We'll be getting to that a little bit later in this course in the customer section, because before we get there, I just want to focus on how the Stripe payment flow works before we integrate a third-party authentication provider and database. And let's continue this in the next part.